tomorrow that we took last Thursday. And the grades, I think, should be finalized. I think. Or did I put a tardy bonus in it?
I don't think so.
I don't think so.
Oh, you should.
Did I say I was going?
Yes.
Yeah.
I kind of need that.
Yeah, I may have to look at that. Yeah, because I thought of that this weekend. I thought I might have forgotten. Okay, so the grades are not final, like I was saying. So hopefully I can get that in. I don't know. I think we were supposed to have it in on Sunday, so I don't know. I'll find out. I know I can change them, but how soon that gets actually done or whatever. All right, so here's some things. I don't know how much some of this introductory stuff you need to put in your notes. It's totally up to you if you think you know this or not. But we're going to do a short run through chapter 6 here, which is basically triangles. Okay, this is kind of the last of our trig stuff that we have to do. Really, we've done a lot of what we'll do with the trig functions. And we'll continue to come back and review it, hit it a little bit, those kind of things. We'll see it again probably on our final exam a little bit too. But so solving triangles. So now we'll be back into degree mode, okay, with all of the stuff we'll be doing. We're using our calculators a lot for these to solve these problems. So just some quick review of things on triangles. Obviously, scalene means no sides are equal. Isosceles means at least 2 are equal. So you could have 3. I mean, so technically a equilateral triangle could also be called an isosceles triangle, but we usually call it by its most specific name. For example, if you have a square, you could call it a rectangle. It's true. A square is a rectangle, but we would usually call it a square because it's got one extra set of properties that makes it unique. And just like an equilateral, if all 3 sides are equal, it is isosceles, but we would say that's an equilateral. Okay, and then by angles, if you have a 90-degree angle, that's a right triangle. If you have no 90-degree angle, and of course you can only have one because all the angles add up to 180, right? The 3 angles in a triangle, so you can only have one 90-degree angle in the triangle. If there is no 90-degree angle, it's called an oblique triangle. And an oblique triangle can either be acute, which means all 3 of the angles are acute, which means less than 90, or it has one obtuse and the other 2 are acute. Okay, so just some triangle basics there. Okay, a couple of other things about triangles. There's the triangle inequality, which basically says that any 2 sides added together has to be more than the 3rd side, right? Because if they were less, that would not make a triangle, okay? That other side would be big enough, or would be too big, I guess. So if that 3rd side, so A plus B would have to be greater than C, and A plus C would have to be greater than B, and so forth, so on, okay? So that would eliminate a scenario where you had, if you were given a triangle and you said, well, this side is 3 and this side is 2 and this side is 7. Okay? Well, that can't be right. I mean, if this is 3 and this is 2, no matter how wide, no matter how far apart you put those 2, if you put the 2, right, if you put the side that was 2 and opened it all the way up and the side that was 3, that makes a length of 5. So there's no way if you tip this one up that was 3, there's no way that distance there could be 7. So any 2 sides add, so that wouldn't make a triangle. I don't think that'll be an issue for us. I don't think we'll run into that in any scenarios, but that's something to just keep in mind. And of course, the 3 angles added up have to add up to 180. The largest angle is always across from the largest side. The smallest angle is always across from the smallest side. Okay, those are just some basic things we need to know. And when we label our triangles, we always use capital letters for the vertices, and so those are our angles. So angle A, angle B, angle C. And then the sides are lowercase, and they are always across. So side A is always going to be across from angle A. And side B is always across from angle B, and side C is always across from angle C. Okay? So those are the things we'll be doing. Most of our work with oblique triangles in this chapter. Okay, we've done the right triangle trig, the SOHCAHTOA stuff, right? Hypotenuse and all that stuff with the quadrants. So this is going to be solving oblique triangles. Okay, so when I say we're going to be solving a triangle, what does that mean? That means we're given 3 pieces of information. We have to find the other 3. Okay, now what are all the possibilities? Well, if you're given 3 pieces of information, there's 3 angles, there's 3 sides. So you could be given the 3 sides, right? Now you guys might remember that geometry. That'd be like, we would call that side, 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 SSS, right? So we might be given 3 sides. Now, 3 sides, well, we'll get in that in a minute. You could be given 3 angles. Angle, 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 right? You could be given the 3 angles. Could you find the other 3 sides? You could be given 2 angles and a side, right? Now, given 2 angles and a side, you could have these 2 angles and the side between. That'd be angle, side, angle. Or you could be given these 2 angles and one of the sides it's not in between. That'd be angle, angle, side, or angle, angle, side. So you'd have angle, side, angle, or you have angle, angle, side. Okay, so you'd be given 3 angles, you could be given 2 angles. You could be given no angles, that'd be side, 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 or you could be given 1 angle. So let's say you're given this angle, you could get, and then you could have the 2 sides that include that angle. So that'd be side, angle, side. Or you could be given 1 angle and the 2 sides that don't include that angle. That'd be side, side, angle. Or angle, side, side. So it could be any of those 6 scenarios. Now, let's investigate. Let's talk about those. If you have angle, 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 what do you remember from geometry about that scenario? Nothing. Is that true of all of these or just that one? Angle, angle, angle tells you nothing about a triangle. Now, what you might remember is similar. Okay? This kind of looks like an equilateral, so let's make it equilateral. Let's say you had 60, 60, 60, right? And this side can be 2 and 2 and 2, right? What about that triangle right there? That's also, and that can be 5, 5, and 5. Just because you know all 3 angles, do you know what the sides are? No. Okay, matter of fact, you had something in geometry called the angle-angle postulate. If you knew 2 of the angles, of course you know the third. That means the triangles are similar. They're going to have the same shape, but not congruent. Congruent means they'd be equal in all ways. The measures of the sides, the measure of the angles be the same. So angle, angle, angle is not what we're going to deal with. If we're given 3 angles in a triangle, it tells us nothing other than the shape of the triangle, but it doesn't tell us about the sides. We would not be able to find those sides. Now, if we know side, 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 that was one of your congruence theorems. So if you knew the 3 sides of a triangle, that was it. That's the size and shape of that triangle. And so if another triangle had those same 3 sides, they were congruent. They were going to be exactly equal. And likewise with side, angle, side. If you knew 2 sides and the included angle, that was going to make a unique triangle. And if one triangle had those 2 sides and that included angle, and another one also had it, they were going to be congruent. Okay? So these are ones that we're going to work with, but we're going to work with those later. Okay? That's going to come in the next section. Okay? Likewise, angle, angle, side, and angle, side, angle also represented unique triangles. If one triangle had 2 angles with a non-included side or 2 angles in the included side, and another triangle had those same measurements, they were going to be congruent triangles. And they were going to be the same size, same shape, same measurements, everything. Those are the 2 we are going to do today, and we are going to use something called the law of sines to solve those. And then we got this guy. What do you remember about that other than you should spell it this way, not the other way? What do you remember about this? That's it. That's the only thing you remember. That's the only thing you remember. I figured. Matter of fact, I knew that, so when we get to it later, I even wrote. I don't know why I thought Seth would be the one usually. I just thought Seth. But it was pretty much everybody. Okay. So anyway, when we get to that, okay. So the side angle scenario was not a unique triangle situation. Okay, now it was more unique than angle. There'd be an infinite number of triangles that were equilateral, right? So if you knew 60, 60, 60 were the angles, there could be an infinite number of different side measurements, so we couldn't even find them, so we wouldn't deal with them. However, with side angle, so if you're given two sides and a non-included angle, then there's either no triangles that have those measurements, there's one triangle that has those measurements, or there's two triangles that have those measurements. It's one of those three scenarios. And so we call this the ambiguous case when we're solving, is it G? Yes. We call this the ambiguous case when we're solving triangles, and you will have to figure that out. You will have to either say there are no triangles, or there's one and here are the missing measurements, or there's two and here would be the missing measurements for each one. And so that will be the tricky one. Okay, otherwise the others that we'll be working with right now, and we're going to do law of sines with this also. We'll do law of sines with this one also. And if it's one of these situations, then it's no problem. We just find the missing ones. There's only one triangle that's a possible answer. We find the missing measurements and there we go. Okay? All right. So let's do this to develop our law of sines here. I don't think you need to write this part down, so I wouldn't worry about this right now. So if we have an oblique triangle, non-right triangle, let's draw an altitude, let's draw on a height. This is with an acute. We can do it with an obtuse also. It's going to work the same. I'm going to draw on a height. That gives me a right triangle. I can do my SOHCAHTOA. So sine of A would equal H over B, opposite over hypotenuse. Sine of B would be H over A. So I get that. Multiply the B over to this side. Multiply the A over to this side. I get H is equal to B sine A or A sine B. Okay, now the B sine A is the one I'm going to remember. Later, that's going to be important when we get to that ambiguous case. Remembering that the height is B sine A is going to be something that could be useful for you. Okay. Well, since they're both equal to height, they got to be equal to each other. So B sine A has got to be equal to A sine B. And so if I divide B over to the right and divide the A over to the left, I get, depending how you want to divide, I could divide the sine A over and the sine B over. Doesn't matter. We get a proportion. So did you do this in geometry? Does this look familiar at all? No. Okay. So B over sine B, A over sine A, or the other way around. Now, the nice thing is the A always matches with the A, the B matches with the B. And we could have done this using angle C. I could have drawn my altitude here, and I've done the same thing. Okay? So here's what you want to write down, the law of sines. And the law of sines is going to be useful for those three scenarios. For sure, when we know two angles. When we know two angles and a side, for sure we're going to use law of sines. Okay, angle, side, angle, right, for sure. Angle, we never use it, right, at all. So we would never be given that. The tricky one is when we have side, angle. We have only one angle, and it's not the included angle. Because when we have the included angle, side, the angle in between is what we mean by included. When we have side, we'll use something called the law of cosines, and that comes later. That'll come on Wednesday, probably. Okay? And that's what we'll use in those cases. So and we won't do a proportion with all three of those. We'll just pick two. Right, whichever two, depending on what information we're given. Now, you can be given your triangles PQR, XYZ, ABC, it doesn't matter, right? I'll usually use ABC, and if I'm giving them as PQR, I'll probably turn them into ABC and then turn them back. It doesn't really matter, okay? My plan is to probably just give them to use ABC all the time. Okay, that's called the law of sine. So it's pretty simple. All right, so let's say we're given this information. So some of the homework problems are going to give them to you as a drawn picture, but a lot of times they give it to you like this. Now, to be honest, it doesn't matter that you draw it to scale. Okay, what I would suggest is always draw angle A in the bottom left corner. That's what I'm going to suggest, and you're going to see why later on. It doesn't matter, but for that ambiguous case, it's going to be helpful, I think. Okay, and now how we draw the rest of the triangle, if you want it, if you're picky about having things be, to scale, you want that to look like an obtuse triangle, that's fine. It doesn't matter. That's 29. And then angle B, or side B, remember, has to go across. So that's angle, angle, side. We're given two angles. That's a perfect thing for law of sines. That's one of our nice ones, right? It's not the ambiguous case. It's not the ASS one. It's the nice one. So what are we going to write? We're going to write sine of 102 degrees over what? Over C. Because that is angle C, so down here goes side C. Now, I don't care which one you write on top. It doesn't matter. I'll show you in a minute because we're going to cross multiply when we solve. And over here, we'd have sine of 29 degrees over 28, right? So you have 4 slots. You have 3 pieces of information. We can solve for the missing. Now, do you guys remember how to do a proportion? You cross multiply here, and then divide by this one. So cross multiply here, then divide by this one gives you the missing one. So you don't need to write it as an equation or anything like that, because then that gets tricky because you got the C on the bottom and you got to do weird things. Law of sines, we're going to do a cross multiply. So now I would suggest, here's another little hint for you. If I'm typing this in, I'm going to type 28 times sine 102, because you know how your calculator gives you that left parenthesis for sine? And then it's a pain to remember to do the right parenthesis. So because if you do sine 102 times 28, you forget to hit that right parenthesis, that's going to be bad. So I would do 28 times sine 102, hit equals. Then you have to worry about that right parenthesis. Then you can divide, and then just hit divide sine 29. So if I'm typing it in, I'm typing in 28 times sine 102, hit equals, divide sine 29, hit equals, and you get what? How much?
56.49.
Okay, it's probably going to say either 1 or 2 decimal places in the problem. So if this was given in inches, you should probably put inches on there. You should put the label on there. Okay, that's side C. Now remember, we got to find all of the missing pieces. Okay, now here's where rounding too early could get you in trouble, and I'm going to get a little picky about this. Okay, now we have 2 other pieces of information to find. Now angle A is easy, right? How do we get angle A? 180 minus 102 minus 29. Right? 180 minus 102 minus 29 is 49 degrees. Make sure you put a degree symbol on that. Okay, and the only other thing we're missing is little a. How can we find little a? Same way we found C. Now let me give you another piece of advice here so you don't have to worry about the rounding. I would like to avoid using 56.49 because it's rounded, and I might have messed up. And if I use a wrong answer now in a subsequent calculation, that's going to be bad. Okay? I have a lot more confidence in my 49. It's not rounded, and all I had to do was subtract, so I feel pretty good about that. So I would probably try to use the 49. Well, I'm going to have to use the 49 because that's what I'm looking for A over here. So I'm going to have to go sine 49 over A, and I would go ahead and use that given one that I had, the 29 and the 28. Now, I could use the 102 and the 56.49, but I like to avoid using calculated values if I can. I'd like to use my given values as much as possible. So sine 29 over 28 would be a better bet. So now we cross multiply. 28 times sine 49, divide by sine 29, and I get little a is 43 point what? 59 inches. Okay, and that is, so here's my final answer, right there. I'd like you to be somewhat organized with it and write it out so you get, so you're given 3 pieces of information, you should answer them with 3 pieces of information, the missing 3. Okay, so it's pretty straightforward. It couldn't be much easier to use, okay? Especially when you have angle, angle, side, which we had here, or you have angle, side, angle, okay, which were 2 of them that were perfectly useful in geometry. So let's do one of those. Here's an angle, side, angle problem. So again, I would put angle A down in this corner, just get in the habit of doing that. These are acute angles. Again, it doesn't even matter. You can draw every triangle like this, even if it's a 130-degree angle. They don't have to be drawn to scale. Okay? This is 58. I would probably put the B over here. That's what I'm going to be doing later in some examples that I do when we get to the ambiguous case. I'm going to put the B over here. Okay, so that's how it's drawn a lot in your book. Doesn't really matter, but, and then the C is 12. So now it's the included side, but it's okay. Angle, side, angle, or angle, angle, side, law of sines works beautifully. Okay? All right, so here we go. Sine of 58 over, that'd be A, right? Equals sine of, no, I kind of tricked you. We can't do 43, can we? Because then we'd need B, and then we got 2 unknowns. So, minor inconvenience. When we get the side in between, it's like, oh, shoot, well, this is easy, right? So we should find that first. As a matter of fact, if you're given 2 angles, that probably ought to be the first thing you do. If you're given 2 angles, find the third, right? So angle C is going to be 180 minus 58 minus 43. That's going to be 79. So that's probably what we should have done right away. And that's always a good number to use. Chances are you're not going to screw that up, so you're probably going to be in good shape. So now we can do sine of 79 over here over 12. Yeah, because we don't want to have 2 unknowns in our proportion. Okay? So we cross multiply. 12 times sine 58, it equals, divide by sine 79. Now again, the only reason I hit equals is so I don't have to close that parenthesis on the sine 58. That's the only reason I do that. Doesn't matter, you can close the parenthesis and then divide. It's probably the same number of keystrokes, so no big deal. What do you get for little a? Oh, and something I was going to mention, and this time it was feet. I was going to mention, it's not bad to double check to make sure that your biggest side is across from your biggest angle, right? Make sure you didn't mess that up. Your smallest side is across from your smallest angle. It's not a bad idea. And any 2 sides add up to more than. It's not that you have to do that as a double check, and just if you mess something up, okay? There is some checking we have to do when we get to that ambiguous case, but on these problems, on angle, angle, side, or angle, side, angle, if you've done the calculations right, it all should be good. Okay? All right, and then what's left? We got, so that was 10.37. So now I got to find B. So now sine of 43 over B would equal sine 79 over 12. Again, not wanting to use the 10.37, just don't want to use anything that's been rounded. Yeah, you can, but you probably better type in 5 or 6 decimal places if you really want to be accurate. Okay, because if you're off in your final answer, and it's because you used a rounded value, you may lose more. Okay, I mean that's how the calculus stuff is graded for sure. They have to be accurate out to 3 decimal places, and they have to make sure they use a bunch of decimal places if they're using a rounded value. Okay, what do you get for B? 8.34. And that would be the smallest, and that is the smallest angle, so that makes sense. That's the smallest side. Okay, so there's your final answer, the 3 missing pieces. All right, pretty straightforward, pretty easy to do. So angle, angle, side, angle, all good. Okay, now, let's move on. So, let's talk about this ambiguous case. Okay? Here's why it's ambiguous. And here's why I always draw A down here. So we're going to do it, our side angle is if we're given angle A, we're given side A, which is the one across, which is the 3 here, and we're given side B. Well, this time it's C, whatever. Most time when I draw it's going to be B. That's going to be this side up here, which you'll see here in a minute. It doesn't matter, it can be down here too, but I'll show you why in a second. So notice what we're given. We're given a side and the non-included angle. So this 30 is fixed, can't move. Now this isn't fixed. We don't know what that angle is. Excuse me. Okay, so we do not know this angle. So we got a fixed angle, and then we got 2 sides, ASS. Okay? All right. Now, in this case, there's no possible triangle. This side's too short. Okay? Again, we don't know what this angle is. Could be anything. It's too short. Okay? So I'm given a 10 here, a 3 here, and a 30 here. It'll just never make a triangle. So one option is, and let's pretend right now. Let's pretend that this is a C. Okay, everybody pretend this is a C. So this is my B. Okay, so right now B is less than A, and it's just too small. Okay, it's too small. Now, if it would have been in here somewhere, if this 10 was a smaller number, and if this thing right here was here, yeah, then it'd be hidden, it'd be fine. But that 3 is less than 10 by quite a bit, and it's just too small. So this would be our case where we have 0 triangle. I call this the swinger. Okay, the swinger.
I feel like these triangles are going to be a pain in the
Yeah, but they're fun. They're fun. They're challenging.
You did yours, joke.
I got you. Yeah, they will be. They'll be a pain in your SSA. That's what. All right. So, too small. Now, if we make it a little longer, it's actually just right. Okay, now actually I'm going to scoot that back. Now it's hard to tell. It's hard to tell when it's exactly touching, but it's actually, whoops. Right here, when that's 60 degrees, okay? Now you won't know this. You won't know this is 60, but the point is, since we know right now that's 30 to 60, that makes this a 90. So when the swinger is too short, it never touches over there, right? If you make it just long enough so that it just barely touches, it catches right there, and then it's too short again the rest of the time. It's going to be when it's an altitude, right? One of the properties you had in geometry was the shortest distance between a point and a line is the perpendicular, right? And that's what that would be. So if you happen to, and so that would actually be the altitude. That would make a right triangle. We'll call that the height here of our possible triangles. This would be that B sine A we were talking about. Okay, B, this length times sine A, that's this height right here. Okay, if you think about it, the sine of A, this is a 90 degree right here. The sine of this angle would be the opposite over the hypotenuse, right? Over the, no, that's hypotenuse. That's the B. I'm sorry, that's the B. Remember we said this is C down here, this is B. So B times sine of A. Hypotenuse times sine of A. Okay, anyway. So it's possible that it's too short. Okay? It's possible it's just long enough. Notice the 5 is still less than 10, right, that we're given. The swinger is less than the other one. Okay, and remember the swinger is always across from the angle. The swinger is always across from the angle that's fixed. Okay? And it's just long enough to just be the height, be the altitude. Or it's possible that it's longer still. Notice it's still less than 10. Now it's long enough to hit once there, when that's what, 93, or more like 94 maybe. And then it'll swing and it'll hit again right there. There's two possible triangles. Again, both those triangles I just showed you have an angle that's 30, a side here that's 10, and a side across that's 6. So I give you the 30, the 10, and the 6, and you don't know if it's that triangle or it's that triangle. See? That's the difference. Now, if I draw this, well, I'm not going to be able to draw it and keep it up there, so it's not good. I'll show you on the next one. So let's look at this one. There it is. This is how I'm normally going to draw it. See the swinger? See, now you can see. This is how I'm normally going to draw it. I'm going to put A down here. I'm going to put B over here, which we don't know, right? Right now we don't know what that angle is. Okay? But we know this side. So again, ASS. Right? We don't know the included angle. All right. Well, right now it's too short. Okay? So that's too short. So that's your 0 angle possibility. Make it a little longer. Make it a little longer. Still a little too short. Still not quite able to touch. But if I make it 4.5, perfect. Okay, perfect. Now it's only one triangle. That gives me one triangle. Now again, that's when this side is equal to B sine A. B, because the sine of this would be this over that. Right? So if we take that times sine A, that should give us this. So B times sine A is this height, this imaginary height. Now that's the magic point where this side, this A side, if it's equal to B sine A, then that's going to be a check for us. Now you're not going to have to use that check if you think it's confusing and hard to understand. Then you can kind of do it the long way, which is you can always assume there's two triangles. And find them and then figure out, oh, but this one won't work. So that's one way. So that's a way to do it too. And we'll talk about both of those. Okay? All right. So, a little too short, you don't have a triangle. Now, I'll show you what's going to happen in your calculation. Something's going to happen in your calculation that will tell that, right? Well, everybody try this right now. On your calculator, do 9 times sine 30. 9 times sine of 30, because right here's the B times sine of A, right? If it were me doing these problems, this is the first thing I would do. I would do B times sine of A. B times sine of A is this height right here. That's this height right here. What do you get? 4.5. So if I'm working this problem, I'm going to type out B sine A, and I'm going to get a 4.5, and I'm going to look at the side A I'm given, little a. I'm going to say, well, that's too short, 3.8. 3.8 is less than 4.5, and I know 4.5 is this height right here. So if I've got a number here that's less than that, if it's less than B sine A, it's going to be just swinging in the breeze there, and it's not going to make a triangle. What if it equals 4.5? What if this side is 4.5? If you type in B sine A and you get 4.5, and the side you're given is 4.5, you're like, oh, there it is. That's a one triangle. It's 4.5. It's the one that exactly matches right here. Okay? What happens if you type in B sine A, you get 4.5, but your side that you're given is 5? It's bigger than the height, right? Well, if it's bigger than the height, that means it's going to hit over here, and then it's going to hit again over here. Now notice that this makes like a little isosceles triangle right here, right? So once you find this angle, right, So this is one of your triangles right here, okay? And then the other triangle is this triangle here. Well, this side's just going to be 180 minus whatever you had there, right? Whatever you get there is just going to be 180 minus that, okay? Well, wait a minute.
That'd be 180 minus.
Yeah. No, it's 180 minus this. Yeah, but isn't that the same thing? Isn't that the same thing? Because this is an isosceles triangle right here, right? So this angle is going to be equal to this angle, so I mentioned 2 more. Okay, so this angle is going to be the same as this angle. So this one's just going to be 180 minus that, right? 180 minus that because of the straight line, 180 degrees. Okay? All right, now we'll see that in action here in a minute. Okay, now what happens if this swinger gets bigger still? What happens if it gets bigger than 9? Now what happens? How many triangles now? Just one. Because what's happening is, when it's way out here, you got one, and then when it's way back here, it's just off the page, right? So if this side over here is bigger than that, remember in all our other cases, this other side, the swinger side, was always less than this other side. If it was too small, you had no triangles. If it was just right, this would be like the 3 bears. One bowl of porridge was too cold, one was too hot, one was just right. Okay, maybe not. That just came to my mind. So the swinger's a little too small, no triangle. If it's bigger, yeah, actually there's 4 possibilities, so that was stupid. So if it's bigger, then you could have 2. If it's too big, you're back to just 1. And if it's just right, that's what I'm saying. Just right. It hits there once, and then you have 1. Okay. But I think this visual could be helpful for you in deciding if there's no triangle, 1 triangle, 2 triangles, and then potentially it keeps getting, if it's too big, then you're back to just 1 triangle. If it gets too big, if it gets bigger than that other side, 9, then it's, okay? Now, the other scenario, and this is a quicker scenario, is if the given angle is obtuse. Well, how many obtuse angles can you have in a triangle? Just 1. So in this case, you're going to have so in the 2 triangle case, one of them will be acute. This one you find here, and then this one will be obtuse because it's 180 minus that, right? Well, if this one's already obtuse, there's no way you can have a second triangle because you can't have another obtuse angle. So if your given angle is obtuse and you're doing the ASS situation, you can either have 1 triangle or no triangle. You can't have 2. Okay, the only way you can have 2 is if this given one's acute and it's the ASS situation, and then those other things happen. Okay, so that's a lot of stuff. So let's see what that looks like in action. Okay, so here's where I wrote this out. Now, maybe we'll come back and we'll write this in our notes after lunch, because I want to do a problem right now with the time we have left. But here's kind of the options. Now, if you look, and don't even look at your book right now, that'll take too long. If you don't have your book out yet, well, but there is a table in the book that kind of has this written out. Now, again, like I said, I'm going to show you a way you can do it without worrying about the B sine A thing, but I think it can be kind of a shortcut for you if you want to use it. Okay? All right, so here's the center. Here's how I would normally draw them. Okay? I would draw my angle A down here. I would put my B up here. A is the swing, right? If it's too short, right? If it's less than the height, there's no triangle. So remember, and what is the height? Height is B sine A, right? The height is B sine A. The height of the triangle is B sine A. So if you just memorize that, the height of the triangle is B sine A. Well, if that swinger A is less than the height, there's no triangle. It's just hanging out there, right? It can't fit. If that swinger A is equal to B sine A, if it is the height, that's that one where it just got long enough and it made 1 triangle. So if the A is equal to B sine A, you got 1 triangle. And then if A is greater than B sine A, you're going to have two triangles. Okay? Now, with the caveat though, on that last one, remember if A is greater than the height, you're going to have two triangles unless A is so much bigger, right? That's when it got bigger than the 9. If it gets so much bigger, that's his top one. So I probably should have written that under here. Probably should have written that down here. If A is greater than or equal to B, so if A is not only bigger than the height, but it's so much bigger that it's bigger than the actual other side, then you're back to just one triangle, because now it's too big. Okay? So maybe that's a way to do those. I didn't really put them in any order when I was writing them, but now I'm thinking about how we talked about them. Maybe if you had them in that order, this would be kind of your first scenario. This would be your second scenario. This would be your third, and then this would be your fourth. That's kind of the order we talked about, if that helps. Okay? So first scenario was that swinger is just, it's less than the height. It'll never reach. So you got no triangle. If it's equal to the height, you got 1. If it's more than the height, you got 2. Unless it's too much more, that it's more than B, then you're back to just 1. So knowing going in, if you have no triangle, 1 triangle, or 2 triangles, can be a nice thing. Can be kind of a little bit of a shortcut. Also, there's some IXL problems, and there's some homework problems where I think all they ask you is there 0, 1, or 2 triangles? So if you're going to kind of do it the long way, you got quite a bit of work to do to figure that out. Whereas this maybe is a little less. Okay? All right, I'll come back to that if you need more of that. Now, the other scenario we said, we're not going to say on this right now, but if that angle down there is obtuse, then you can only have 1 if A is greater than B. But if A is too small, again, if A is too small, you got none. So if A is less than B, we don't have to worry about the height. There is no height because if the height would be outside the triangle out here, right? So we don't even worry about the height. So if A is littler than B, it's just going to be out here just swinging, and it's not going to make a triangle. But if A is more than B, then it'll hit down here somewhere. We'll just have 1 triangle. Okay. All right. So let's look at a scenario. Okay. All right. So let's do this problem. We got enough time here, I think, to get into this one. So right away we draw it, and we notice it's SSA. Okay. It's SSA. So what I have here is, right, I got this scenario right here. Now, what I don't like about this is it doesn't have my angle down in that left-hand corner like I like. Okay? So here's what I would do. I would save this one for later. I don't like the order of doing this right now. Because remember what I said? I said if you don't have to do the B sine A thing, the height thing, you can kind of work it through. And I want to show you both because I want you to, if you're not comfortable doing this other one, you don't have to. Okay? So that's what I wanted to do with this one. So I'd rather do this one right here. Okay? So let's do this one right here. Because this one does have the A. I'll show you. We could just change those letters around. Okay, we could just change those letters around or put the C, put the angle I'm given down there, right? I like it better if it's A than it's the given one, but we can figure that out. Okay. All right, so I would go ahead, so let's go ahead and do this one. Okay, so angle A is 85 degrees. Doesn't matter if it looks like 85 or not. Okay, side A is the swinger over here, right? I'll draw it a little short just for now, just so we know that's the swinger. We don't know. Now we know side B, so remember I'm going to put side B over here. So we'll put B right here. So this is side B over here. This is 25. So there's my ASS situation. This is my swinger. I don't know what angle B is. I don't know what angle C is up here, right? So the question is, so we go through the process. So is this too short? Right? Is it too short? Well, how would we know? What do we have to calculate? B times sine of A. Because B times sine of A is going to be that right there. B times sine of A, right? Sine of this equals that over that. So we take that times sine of A. So now, if you always draw it this way, let me just show you this now. And we'll do this on that other one I was talking about. It doesn't matter anymore if this is A or not. When I say B sine A, it's this times sine of this. It's this times sine of this is going to give you this height. So whether this is A or P or Q or X or Y or Z, doesn't matter. It's this times sine of this is going to be your height. I always call it B sine A. I call it B sine A because normally I want my triangles this way. But if they're not, it's just this times sine of that. What do you get? 25 times sine of 85. 24.09. So what do you know about this 15 right here? It's too short. So what do you know? No triangle. And you'd be done. Okay? Now, we got just enough time for lunch. No triangle is not too hard doing it without doing that. Let's say you didn't draw it like that. You just went ahead and drew your triangle down here and you set up lost signs. Watch this. Sine 85 over 15. Are you with me? Right? See how that'd be? Equals sine of what? Sine of, there you go, sine of B over 25. Now let's cross multiply. Okay? Take 25, quick, bells ring. 25 times sine 85, divide by 15. Now remember, we still have a sine B there though. Sine B equals what? What do you get? Sine 1.66. Can sine be more than 1? Right now, to find B, what you would normally do is you do inverse sine right now, right? You do inverse sine. Guess what? You're going to get an error. Now, you probably don't even need to. You just know, hey, that's more than 1. Oh, when you get an error, what's that mean? No triangle. So, you see what I mean? So, if it's a no triangle situation, setting it up, going through it, you'll figure out that it's no triangle, right? But we can also see it's no triangle because we did this B sine A. We figured out what this height was. It's that 15 is too short. It's too short. It's just going to be swinging in the breeze there. It's not going to make it. Okay, so that's no triangle. We come back and we'll do some 1 and 2 triangle situations. Right. All right, let's get back to it here. Okay, so let me clarify one thing here. So I may have misspoken here when I said we always want to put angle A down in this bottom left corner. I meant the angle you're given in the bottom left corner. Okay, the angle you're given. So in our example, our initial example, that's where A was. So that's why all the ones I drew, and then that's why that one that came up 3, we're going to redraw that one, and so we'll get to that in a minute. So the one we just did a minute ago, number 4, that one already, that was given, that one had angle A given to us. So what we want is the angle we're given here. The swinger is always across from there. So that's always the one over here. So that'd be little a. And then, or it could be something else. If this is angle C we're given, that'd be little c, right? So the swinger is always across. And then we want the other side we're given to be this one up here. Okay, so when I talk about the height being B sine A, in this example, it would be that times sine of that. But if this is C down here, so it doesn't have to be B sine A, it has to be this side times sine of that. So if we always draw them this way, with the angle that's given down here in the bottom left, this fixed side here, and then our other side, the swinger, across, then it's always this times sine of that, and that's our height. That's our height. And then that's what tells us if it's too short, or just right, or long enough that we could get 2. Okay, so if we're wanting to do it that way, that would work. All right, so in this, so we're back to this one that we just did. So we drew our 85 down here. We drew our, and remember, A and A always have to be across from each other. Now remember, all this that we're going through is only when we have the SSA. It's only then. If we have the other two, if we have angle, side angle, or angle, angle, side, then they're easy. We just write them down, we set up our law of sines, we cross multiply, we go, get our 3 unknown parts, and we got it. So just like what we did before, this is only when we have that situation. Most of the time you won't have that situation, right? Or a lot of the time. 2/3 of the time, maybe, whatever. Okay, but when we have this situation, we got to make sure we put our angle down here, and this side, we got to make sure we get the swinger, the right one. That's always the one that's across. So if A is our angle, 85, then the 15 has to go across. And the 25 goes here. Then we do this times sine of that. That gave us 24.09. That tells us our height is 24.09. That means that's just too short. At 15, it's just going to be swinging there, and we're not going to make a triangle. Okay, let's go back to this one then. So here's what I would do if I had this scenario. Because sometimes they draw the triangle for you. Most of the time, I'm just going to give you these numbers so you can draw it wherever you want. But sometimes they draw it for you. So if they had already drawn this one like this, I would probably redraw it. So I would go and say, okay, 42 is my angle I have. I'm going to draw it down here. So I'm going to put that, I'm going to put the angle they gave me here, the 42. Now, which one of these two is the swinger? 12 or 22? It's always the one across, right? It's 22 is across from 42, so that means 22 has got to be this one over here. It's got to be. Okay? So that's the little c. And then I want B to be over here. I want the other one I've given to be here, so that means I'm going to call this B. So they called it B right there. They called 12, the other one that I'm given, to be B, so I'm going to make that be B and make that be A, right? So first thing I do, I notice I have SSA. I'm going to say, okay, I want to take that angle. I want to stick it down here in the bottom left. That makes it easier because then I always have the swinger up there and I can always visualize that thing we talked about. Okay? So now the question is this too short? Well, definitely not. I mean, look how big that, how long that is. 22, right? I mean, compared to the 12, right? But we could do B sine A. Now, it's not really B sine A. It's actually B sine C. But we would do 12 times sine 42. So if you're wanting to do this method of getting the height and thinking about what my options are, let's do it. So what's 12 times sine 42? 8.03. So is this long enough? Definitely is long enough. Now, it might be too long, right? It might be too long, so I might have 2. But since it's more than, so imagine this thing swinging back and forth. What's going to happen when it swings over here? it's going to go way past, right? Because 22. Let's go back to that picture. Okay, so right here, see, we got this one. The swinger is 5.4, but what we said is when that swinger gets to be 9, see, look what happens is this side gets longer and longer, right? Once it hits 9, it's way over here, and once it's longer than 9, it's way out there, right? So what we have is the swinger side is way big, so it's going to give us one triangle out here. The second triangle's not even in the picture, okay? So it's so big that it's going to be just a one triangle scenario, okay? So now that we've identified that, we can just go on with our work and not worry about it, okay? Later I'll show you, probably tomorrow I'll show you what we could have done without doing the B sin A to show that second triangle is not an option. Remember I said you'll have to assume that there's two triangles, right? Now you wouldn't do that here with this thing we got an error. Right away there you know there's none. But otherwise, if you do get one triangle, you have to assume there's two and then notice that something's not working, okay, if you don't do it the way we're doing right now. Okay, so here we go. We're going to set it up. So now that we've kind of got that preliminary work out of the way, we can set up sine of 42 over 22 equals sine of b over 12, because here's the b, right? That's what we don't know. So, and then we have the 12 here. So we're going to cross multiply. Okay. So sine 42 times 12 divide by 22. What do we get? Now remember, that's sine b is what we get here. We're going to have to do inverse sine in a minute, right? Because that's this other side we're finding is sine b. What do we got? Sine b equals what? 0.36, dot, dot, dot. Okay, now, this is worth reviewing a little bit. What quadrants is sine positive? 1 and 2. Well, aren't those possible angles that could be in a triangle? See, this is this is part of how you would do it if you weren't going to do this B sin A thing that we're doing to tell right away. We already know there's only going to be one triangle. Okay, we know there's only going to be one. The second one would be this side's too big, this swinger's too big. But if we weren't doing that, right here you'd have to go, okay, inverse sine, so go ahead and do it. Do inverse sine. What do you get for B? Do inverse sine of that. Now don't do inverse sine of just 0.36. Again, that's rounded. What you should do is, once you get that 0.36 number in your calculator, then clear it out and then do inverse sine and do answer. Second answer would be your best bet. Because then you keep all those decimals. Second sine of second answer. And what do you get? 0.41 degrees. Now, if we go back to what we know about quadrants and stuff, we know there's another angle that would be 180 minus that, right? We know there'd be a reference angle. We know there'd be 21.1, but there's another one over here. But remember, look, we said that. We said that before. Remember, we said that before. We said if you're going to have two triangles, one of them's going to be this angle for B, and then this is going to be 180 minus that, right? We already said that because of this isosceles thing. So if we know we have two triangles, that's what we would do, right? If we know we're going to have two triangles, we'd get this one, and then our other possibility for B would be 180 minus that. If you're not going to use the B sin A thing here, which has already told us there's only one triangle, you would have to write that down. You would go through all the possibilities. Now what you'd find out is that second triangle, there's something wrong with it. The sides don't match up or something is wrong. And that makes that a little trickier. So that's why I like doing this. But again, different people, certain things make sense to people differently. So I'm going to show you that. So anyway, we know there's only one triangle, so we're good with that. We're going to stop with that. We know it's going to be that one. We know it won't be the other. Okay, we know it won't be the other. All right. Now, what else do we have to find? So that's 21.41. Well, now can't we find this angle here? So angle A is going to be 180 minus 21.41 minus 42. So that's going to be what? 116.1. 59. So that's angle A. And then we just need to find side A. So sine, I would try to do the ones I know. So sine of 42 over 22 would equal sine of A. No, not sine of, what did we say A was? 116.59. Okay, we have no choice but to use a value there, and then that's little a. Okay, now we're probably okay. We're okay as long as we go out a couple of decimal places on that angle. We're probably okay here, because then we're going to do the sine of it, and so that's going to that usually doesn't throw us off. And so what do we get on that? So then we cross multiply this times that, divide by that. I think I got 29.40. See that? 29.40. So there's our, now we should be a little better organized with all that, but there's our three answers. There's our three answers. Now, to give, it would have, you know, you can kind of balance it out how it worked. Remember we said that if you weren't going to do the thing where we already knew there was only one triangle, when you do 180 minus this, you get like 159 something, right, as the other possibility. So if B is 159, when you add that up to 42, what happens? You go over 180. See what I mean? So that's what I'm saying. That's the point you would know. Oh, okay, there could have been two, but that second one's not going to work. Because that other possible angle for B is not going to work in that scenario. So that's what I mean by something's not going to work. Okay, so would that have been just as fast as doing this other thing? Okay, maybe. Although, if I was doing a question where all they wanted to know is there no triangles, one triangle, or two triangle, we knew there was one triangle right away. As soon as we calculated this height, right, and then we saw that the 22 was too big, this swinger was bigger than the 12, and so it was going to be one over there, but when it swung over, we wouldn't get the second. We'd have known one right away. We wouldn't have known there's only one triangle until we did all this work, or most of this work. So that's why it would have been real short. Okay? All right. Let's try this one. Okay, draw it first. Let's see if you can draw it and put everything in the right places. Once you get it drawn, you can look up here. Okay, agree with the drawing? How many people are already going on and doing some calculating? Yeah, okay. So, that's fine. But now, let me just, so, you know, I talk about a lot of stuff, so it's probably time to try to reorganize it here and get it in some sort of order now that we've been through all the possibilities. Okay, so first of all, put the C there. You know the 12 is C's got to go across. That's a swinger. So then the question becomes this. So now several just things that you can sort out to tell how many triangles you have. First of all, what would be the scenario where right away, we just had it in the last problem. If this is bigger than what? Not even the height. Before we talk about the height. If this is bigger than this, what do you know? You have one. Right away, you know you have one. Okay, that's a scenario we just talked about. If the swinger is bigger than this side here, not only is it going to be big enough, to at least have a triangle. It's going to be too big to have that second one over here. That's when, if this was bigger than this, we'd have one, and then the other one switch. So we would know we would have one. Boom, right away. If the swinger's bigger than that side over there. But most of the time it's not good. Okay? So this time it's not. So then what's the next question? Is it big enough? Right? It's not bigger than this. So now the question is it just swinging in the breeze? So that's when we need the what? That's when we need the height. Right? So if you're going to do it this way, then the next thing would be to take 31 times sine of 20.5, because that's going to be this height right here. That's going to be this height right in here. And that's to see if it's going to be big enough. Because if it's smaller than that, we know it's just swinging in the breeze and there's no triangle. Right? So we already can narrow down some things. What do you get right there? 10.86. So clearly it's big enough. So how many are you going to have? You're going to have 2. You know it's not too big to eliminate one of them. And you know it's not too small to just be swinging in the breeze to have 0. And it's not perfect, right? It's not just right. If this would have come out to be exactly 12, then we'd have known, oh, that swinger is going to come down and just hit right there on the height. Then we'd have known we'd add 1. Okay, so it's big enough, and it's not too big, so we're going to have 2. So what are our 2 going to look like? They're going to look like this. And this is when a lot of times when I draw this in. So that, this picture we had back here, okay, this picture we had right here. So sometimes I like to draw that, and there's my 2. Okay, so the one where this is 12, but then it could be the one where this is 12 over here too. And those are my 2. So when you get 2, I kind of like to draw that. That's this. Then that gives you that kind of this isosceles thing here. Okay, so you could call this your A1, and you could call this one down here your A2. Okay, it's not. You don't have to. I'm not going to make you draw that. Okay, you don't have to draw that. But I'm just saying that's why you're going to have 2. Okay. All right, and now we know there's going to be 2. So if the problem was how many are there, you're done, right? There's going to be 2. You'd be done. Okay, but now we got to find it. All right. So what are we going to set up first? So sine 20.5 over 12 equals, and that'd be for either one of these. The 12 is across from the 20.5. Equals sine of A over 31. Right? And so, cross multiply. We get sine of A equals, I'm not saying you have to write this every time, but I like to write it. It reminds me that there's more than one possibility. Sine A equals what? Point what?
9047.
9047, which, again, there's 2 different angles, first and second quadrant, where that can be. So, A, your calculator is going to give you 1. Remember, inverse sines, restricted to first quadrant, fourth quadrant, all that stuff. Of course, we're not going to have to have negatives when you're dealing with triangles. You're not going to have any negatives to worry about. So, you're going to get a quadrant 1 angle every time. What do you get?
64.783.
Let's go 1 decimal on our angles. 64.8 degrees. And what's the other possibility? I'm going to write that way over here. The other one would be 180 minus 64.8, but it'd be good to use the unrounded. It'd be good to go 180 minus and then to go answer. Using that answer key can be pretty nice because then that can save you from rounding error. But what do you get? 115 point, does it round to 0.2? Probably does, and so you're probably okay. So that is our other possibility. So I got my second triangle going on over here. Now you can call it A2 if you want, but I don't care. You don't have to. But kind of keep them together. So now we got two problems going for the rest of the way. Okay, so let's go back to my original one over here. Okay, so I found angle A. So what else am I missing? I'm missing angle B. What's angle B? Well, that's going to be 180 minus 180 minus what? minus 20.5, right? Because I just found angle A to be 64.8. Now, you could write those in there. I mean, if you wanted to, it gets a little messy. You could have written the 64.8. Now, we got two different angle Bs. We got this one, and then we got that one, depending on which triangle we're doing here. So it gets a little messy in the picture. It just, if that helps or not. So if we want to find angle B, we got to do 180 minus that, and what does that give you? 94.7 degrees. So that's angle B. And then what's the missing side we don't have? Little b. So we're going to need sine of, now again, I would always use the one I was given. So sine of 20.5 over 12 equals, and then I would do this other one I was given, the 31. So I don't have too many rounded things to mess with here. I would do sine of 64.8 over 31. Wait a minute. That's not right. What am I doing? I need B. Never mind. I can't do that because I need B. I need B. So I got to use the 94.7. So sine of 94.7 over little b. Okay? Now I cross multiply those. What do you get? 34.15. Okay, that's one set of answers. Okay, that's one triangle. The three missing parts. Now I got to get the other triangle. So now I got B. Well, that's going to be 180 minus the 20.5. Now it's a different reason I'm subtracting 180 here. Remember, the reason I subtracted 180 here was because I had sine of B, sine of A equals 0.9047, and I had to get, right, I had to get different possibilities for angle A. So that's why I'm subtracting 180 there. It was because of this thing right here, right? But now I'm trying to find the third angle, this B right here. So I'm going 180 minus 20.5 minus 115.2, right? So I just found, let me write that in red here. This would be 115.2. So now I got 180 minus that. It's going to give me that little angle B up there. What do you get for that one? 44.28, 44.3. Okay, and then it's side little b that I'm missing. So again, sine of 20.5, use my ones I was given. And then this time it's sine, not 94.7, but what? No, because we want B down here. So we need B. So we need 44.3. Right? So we want sine of C over C and sine of B over B. 44.3. So keeping all of it straight, right? Being neat with your work, keeping all of it straight is where it gets a little tricky. And then just to help us out here, I had 2.93. Now, it makes sense that little b down here would be small in that one. Look at my picture. It makes sense that that would be a pretty small side right there, 2.9, right? Because when this thing swings, it makes my second triangle over here, right? That was 34. That was because it was way out here. And when it swings over, it makes that side B a lot smaller, okay? But it was it's this situation we're getting right there, where that swinger is bigger than the height, but it's not too big to go way out over here, okay? And it gives us those two triangles. All right, last thing then is if you had a set of problems, something like this. Just write a couple of them down. I don't know if we want time to go through all of them. But if you were given some triangles and it just said how many triangles are there? I think there's some of this in the IXL. Now, you don't have to do the IXL for tomorrow. It would be good to do it this week, right? I don't know if we'll get to a quiz. Will we get to a quiz on Friday? I don't know. No. No. Yeah, you're right. Let's do it the Monday we come back from spring break. That'd be way better. Probably going to do that. We got something called law of cosines to look at. So we do a couple days law of sines, a couple days law of cosines. That would probably be the smart thing to do. kind of get that done and out of the way before we have a break. So it would be good to do that IXL this week. It's down over there, the M13. And some of the questions on that are, how many triangles are there? Okay, well, what are you going to do? I would make sure I always set them up this way. Always set them up with the angle down here in the bottom left. And that's the swinger, right? That's the swinger right there. Okay, now, let's see how we're doing. I know there's a lot thrown at you today. That's the swinger. So what do you notice right away on this one? Because 8 is bigger than 5. So it's definitely not going to be just that little one swinging in the breeze. So, and it's too big to have, not at most one, you actually know for sure you're going to have one. The only way you have none is if you got that swinger that's just, can't touch anything. So right away you know one. Okay, right away you know one. Now, if you're doing it kind of the longer way, you'd have to set it up, do your lost signs, da-da-da, you get an error. Well, no, you wouldn't get an error. You get the one calculated, then you would do 180 minus that, and you'd say, oh, that adds up to more than 180. Quite a bit of work compared to doing this, right? So that's why I think this is much better to understand. Okay, go to the next one. Now you notice that the 4.5 is not bigger than the 6.8, right? So that'd be the first thing I would look for. Is that swinger too big? And if that's the case, it's 1. Now, if it's not too big, then the question is it what?
Too small.
Too small. So what do you calculate? So you're going to do 6.8 times sine of 15. Everybody do it. Do 6.8 times sine of 15. So the first thing is the swinger too big? If the swinger's too big, it's only going to be 1. Too big means it's bigger than this other side over here. Then it's going to be 1. Boom, and you're done. Is it too small? That's when you have to do your height. That's your B sine A. What do you get? 1.76. What's that tell you? It's good. And then how many are there going to be? There's 2. So it's not too small, that it's just swinging in the breeze. So you're going to have 2 right away. So you know you're going to have 2. Okay? Very light. Let's do this one. What do you notice there? It's bigger, so you're going to have, wait a minute. We'll have to talk about that next week. What? Hey, let me think about it. Yes. Well, here's why. Here's why. Right there. The obtuse. Remember, obtuse, you can only have at most 1 or none. When you have none is when this is too small. So yes, this is going to be 1. So anytime that's bigger than that, yes, you're going to have 1. And if it would have been small, which I didn't put that in here, you'd have had that. Okay? We'll talk about the other ones tomorrow. So,
oh my gosh, I was just putting my stuff away.
You thought if you put it away, I'd forget to give you all.
Yeah. Something like that.
Now remember, most of these probably are going to be just the angle side or the angle side angle. Whenever you're given 2 angles, that locks you in. You're going to have 1 for sure, and you just do it, set up your proportion and go and find your missing piece. Okay? And so those should go relatively quick. Okay, it's only the ASS.
Funnier as a freshman.
No, that wasn't me.
It's a lot funny. That's good. That shows progress.
Yes.
It shows maturity. I like it.
You're doing great.
That was that.
You're going to have to tell her to be excited. Yeah.
What?